Good morning. Today is Tuesday, March 24th. Hello, Geometry Honors, periods 5 and 6. It was good seeing you on Zoom yesterday. Now we're back to another video. So today's video is how can we find the area of triangles and regular polygons? It's not just your basic triangle stuff. There's more to it, of course. So, given triangle ABC with A equidistant from B and C, I'm going to draw that. A, B, C, and A is equidistant from B and C. By the way, if you didn't yet, you should print out your handout for this day because you're going to have to send in the notes and the homework, because the homework is just to finish whatever notes I don't finish in class. So I'm going to try to do a little bit of each part or a lot of each part, and you'll have to finish whatever we didn't do. So what is the distance from A to the midpoint of BC if BC equals 8 and A is 10 units from both B and C? Now, I drop the altitude here. In an isosceles triangle, when you drop the altitude, right, you end up with two congruent triangles, okay? So, in fact, if I reflex the property here, hypotenuse leg is congruent to hypotenuse leg, we know they're congruent. So that would make this 4 and 4. So I'm trying to find the distance from A to the midpoint of BC. So here's x to the Pythagorean theorem. 4 squared plus x squared is equal to 10 squared. 16 plus x squared is equal to 100. X squared is equal to 84. Take the square root of both sides. X is equal to the square root of 84, which is the square root of 4 times the square root of 21. So x equals 2 radical 21 in simplest radical form. Okay, so that was that. We also know that the area of a triangle is 1/2 BH, 1/2 base times height, right? Right here, and you all know that already. Find the area of each triangle. So just important stuff to know. This comes up on the Regents. It comes up on the ACTs and SATs all the time. They want to know if you know how to do this. So here, the area is equal to 1/2 base times height, 1/2 14 times 5. The height has to be perpendicular, not slanted. So it ends up being 35 square units. Okay. Here, they love this question on the ACTs. It's where it's on the outside the altitude. But once again, 1/2 8 times 11. The area is equal to 44 square centimeters. And when you have the area of the right triangle, it's always 1/2 leg times leg. Area of a right triangle equals 1/2 leg times leg. And the two legs are the two sides that make up the right angle. So it's 1/2 of 24 times 7. The area is equal to 84 square inches. Area of an isosceles or equilateral triangle. Okay? This one we're going to be able to do because of the do now on top, so you'll be able to follow along with that one. And over here, the area of an equilateral triangle is really done the same way. Okay? This one's upside down, but I'll do this one. This will be part of your homework. If I draw from here to here, you know, those are congruent. So this would be 10 and 10. That would be a right angle on both sides. That's x. Area is equal to 1/2 base times height. Now, some people might realize, since it was a 30, 60, 90 now, because if this is an equilateral triangle, that'd be 60, 60, and 60, and if that's 90 and 90, that's 30 and 30. So if opposite 30 is 10, opposite 60 is 10 rad 3. If you didn't know that, you would do the Pythagorean theorem, and you would still end up with 10 rad 3. Okay? So you would end up with 10 squared plus x squared is equal to 20 squared, right? And then when you did, you would get x squared equals 300, x equals the square root of 300, which is the square root of 100 times the square root of 3, which is 10 radical 3. But again, we could have just got it by the 30, 60, 90. So the area of the triangle is equal to 1/2 base times height, 1/2 20 times 10 radical 3 gives you 100 radical 3 square meters. Okay, again, this one here is part of your homework and not a problem. Okay, page 1 done out of 3 pages. Next thing we're doing is for the area of a scalene triangle, given all 3 lengths without a height, you can use a formula called Heron's formula. The area of the triangle is equal to the square root of s times s minus a times s minus b times s minus c, where a, b, and c are the sides of the triangle, and s is equal to, it's called the semi-perimeter, and it's 1/2 of a plus b plus c. So we are going to do one of them together. We're going to do this one together, and you're going to have to do this one as part of your homework, okay? So we're just going to go right to the formula. Well, first I need to know what s is. S is equal to 1/2 of 9 plus 13 plus 14 9 plus 13 plus 14, 1/2. S is equal to 18. The area is equal to the square root of 18 times 18 minus 9 times 18 minus 13 times 18 minus 14. It's equal to the square root of 3,240. So A is approximately, it says they want it to the nearest tenth. A is approximately 56.9 square units. Okay, so S is a semi-perimeter. You get it by 1/2 of the sum of the 3 sides. So 18, and then you plug it in. Semi-perimeter times the semi-perimeter minus one side times the semi-perimeter minus the second side times the semi-perimeter minus the third side, and you do all that. Okay, this one is part of your homework over here. And lastly, we have area of a regular hexagon with side length equal to 6. Now, you might recall that a regular hexagon, okay, let me see if I can make this a little closer. Okay, a regular hexagon, sorry, I just wanted to see if I can do that better, is equilateral and equiangular. That's what the word regular means. Equilateral and equiangular. Equilateral, all sides congruent. Equiangular, all angles congruent. Okay, so there's a formula here, which is that the area of a regular polygon is equal to 1/2 the perimeter times the apothem. area of a regular polygon area equals 1/2 the perimeter times the apothem. Okay. The apothem, you might say, what is an apothem? An apothem is a segment drawn from the center perpendicular to a midpoint of the opposite side. Okay, an apothem is a segment drawn from the center perpendicular to the midpoint of a side. So here, if I draw in this regular hexagon, and like showing you coming together why this formula works, but well, I'm going to find here. Not bad for not using a ruler. Anyway, but you should always use a ruler. Okay. So I have 6 congruent triangles, or if I, or I could use, if I use the half triangles, then I have 12, but I'm using the triangle down here. So the area of this triangle right here, if this is 6, this whole thing here is 6, also the big side, which would mean that these are each 3 and 3, right? And now, if you did a full circle and divided by 6, you would get 60, 60, 60. So each of these is 60. But then this would divide to be 30 and 30 in there. And if you did, well, and this is an altitude, so this leaves 60 for here and 60 for there. So you have a little 30, 60, 90 right here. I'm going to draw this bigger. So 30 and 30, 60 and 60. And if opposite 30 is 3, then opposite 60 is 3 rad 3. So the apothem ends up being 3 rad 3. So it's 1/2. The perimeter is 6 times 6 sides is 36. And the apothem is 3 radical 3. So it ends up being 54 radical 3 square units. Now, if I would just get the area of this right here, the area of this triangle, and multiply it by 6, it should give us the same result. So if I did area of a triangle equals 1/2 6, 1/2 6 times 3 rad 3, half of 6 is 3 times 3 rad 3 is 9 rad 3, and then I did 9 rad 3 multiplied by 6 triangles, would end up with 54 radical 3 square units. Either way we did it, whether we use this formula or whether we found the area of one triangle and multiplied it by how many triangles there are. So this is, well, we did it. This is using the area of a regular polygon using 1/2 the perimeter times the apothem. So we could either do it separately like this or just use this formula. Now, hold on the back of this, on the next sheet, we have, on the next sheet, we have 4 problems. I'm going to do 1 or 2 of them. Actually, yeah, I'll do 2. One of them, I'll do the hardest one, and I'll do an easy one. or I'll do the harder ones. Let's see. Here. 1 and 3 are very simple. Just follow the formula. 1/2 the perimeter times the apothem. And they give you the stuff that you need. The other one, 1, 2, and 3 are all very simple. You're just following the formula and they give you everything you need. Number 4, I'll do with you because that's a little bit harder. Here we go. Okay. I bring this up to here and this to here. Okay. If that's 4 rad 3, and this now, the hexagon is the one that's special. The hexagon always makes the equilateral triangles, which is nice. That's why teachers use the hexagons a lot. So if this is 60 and 60 and 30, so if opposite 60 is 4 rad 3, then opposite 30 must be 4 by the rules of the 30, 60, 90. Okay? And then if this is 4, making a side 8. So the perimeter is equal to 8 times 6, which is 48. Okay? So the area is equal to 1/2. The perimeter is 48 times the apothem, which is 4 radical 3. So the area is equal to 96 radical 3 square units. Numbers 1, 2, and 3 are just done by the formula 1/2 the perimeter times the apothem, and they gave you enough numbers to be able to figure out what everything is. It was only this one we had to figure out what it is. And for those who don't understand the 30, 60, 90, maybe you remember this. Maybe this will help you. X, X rad 3, and 2X. So if this is over here, if this is 4 radical 3, then this is 4, and 2X would be 8. So anyway, the answer was this. We have now finished the lesson. It was a 17, well, it's going to be around 18-minute lesson, and you're just going to do whatever was not done, and you are going to email me, or wait, actually, my hope is to put this on Google Classroom. I'm going to try for you to download it there instead of emailing it to me. I'm going to try to set that up. But I think I just have to name an assignment, and then you could put it there. And if I have to put the sheet there, I will as well, and that way everything will stay on Google Classroom. If you're unable to do it that way, then you'll email it to me. Anyway, hope you all have a great day, and it was great seeing you all yesterday online. Take care. Thinking of you. Be safe, and take care. Bye.